on public key infrastructure. Actually, I have to discuss here something. What is the public infrastructure? And I will start with very basics. What are the basics of this? And in between, I would like to share some certificates, codes, how we can create certificates, and what are the certificates actually. So our discussion is basically on this topic. What what is the basic problem? Why this PKI is considered? So basic discussion goes to this one. So I will start with cryptography and basic idea of digital signature and basic idea of digital certificates, and finally what is the PKI and how we can achieve this, how we can create certificates. This part is included in between. So what is confidence and trust? Actually, a day before I got an email, and this email from the host of this workshop. I read this email and finally I joined this Zoom here, and now I'm in between you all. So what is behind that email? Behind that email, it was the confidence that particular mail is coming from particular person, and I can trust that person, that mail is coming from right place. So this was the scenario in digital world. If someone is sending to someone some information, someone can trust that information is coming from particular person, and this information is true, information is valid, information is not modified. All these features are included in some information. Okay. So basic problem is, suppose party A wants to discuss with party B, Bob wants to talk with Alice, and in digital scenario, when they are communicating between, they are talking between, so there is in between internet, extranet or intranet, whatever, some medium is required in between. So in this medium, some guarantee is required that will create confidence and trust. From where this confidence and trust will come? Question is this one. Basically, confidence and trust, if we talk about this, so these four parameters comes in picture. First one is authentication. Authentication means whatever information I am getting, that information is coming from right place. Whatever information is coming, that is coming from right person. This is the authentication. Validity is there. I got an email from Mr. X. That email is coming from Mr. X. Surety of this is authentication. Second one is confidentiality. Whatever has been sent to me, that is only I can read that. No one other than I can read that information. So confidentiality is another parameter which must be fulfilled in communication. Next one is integrity. What is the integrity? Actually, integrity is, if someone is sending me some information that give me 100 rupee, then there is no possibility that in between anybody can change, please send me 2000 rupee. So information cannot be changed. That is integrity. And last one is very important, non-repudiation. In case if someone goes to court to claim that particular information is coming from particular person, then the person who has sent that information should not be able to deny that he sent it. He did not send it. If A has sent some information, then A cannot deny. So this guarantee is given. In that case, we say that communication is non-repudiated. So these four basic parameters to be fulfilled uh, to achieve a proper, a valid communication between two parties. So solution is cryptography. All these four parameters, some primitives are in cryptography, which are basically starting with the very basic idea of cryptography. Cryptography, what does? Actually, if some message is given, so scrambling of this message is done through some algorithms, through some protocols. So study of these all things comes under the ambit of cryptography. A word comes crypto system. Actually, 5 parameters are there, and the collection of these all five parameters is called crypto system. So first one is plain text space. Plain text space is means all the possible messages to which we have to code, we have to save, we have to encrypt, whatever we can say. And another is ciphertext space. Ciphertext space is actually the space where all the messages comes, scrambled messages are coming from ciphertext space. Actually, light has gone on this side. So now my fan is not working at this time. So I'm sweating a lot. So plain text space is the domain from where all the messages are coming, and ciphertext space is where all the scrambled messages are there. And third thing is key space. So key is chosen from this space, key space. So all these three spaces, plain text space, ciphertext space, and key space, along with two algorithms. First one is encryption algorithm, and second one is decryption algorithm. So we are having these 5 components: plain text space, set of all plain text; ciphertext space, set of all scrambled messages; key space, set of all keys; and encryption algorithm and decryption algorithm. The collection of all these 5 parameters is called crypto system. So this is mathematical definition of actually a crypto system. So if we see seriously, all the cryptographic algorithms are taking 3 things common: message digest, secret key, and public key. These things are common, very common. And I think most of the primitives are based on these 3 primitives. So first primitive is here, message digest. What is message digest? I will not explain a lot of about message digest. Simply, I would like to say that an algorithm which takes any input of any length and converts that message to a fixed length, so that some properties are there that if some hashed message is given, that cannot be converted. You cannot get vec lengthy message. Also, you cannot find two messages whose hash value is same. So some rules are there. I would like to recommend here a book. Book is D-Stinson. D-Stinson's book is very good, and I think mathematically a very good book. That from there you can see in detail the hash functions. So hash functions, basically we have to have some idea that some function is there. If we are giving any length message to this function as input, finally as output we get a fixed length message, which is for which it is very computationally infeasible to recover the plain text back. So this is the property of message digest hash algorithms. So MD5 is very famous common algorithm. SHA 256 recently there is in picture. Another is secret key primitive. Secret key primitive is these Blowfish, DES, IDEA, triple DES. These all things comes under the key secret key primitive. In secret key primitive, what happens? We also say that symmetric key cryptography. Sometimes it is called. So in this encryption and decryption, what is done with the same secret key? Key is common. So this is called secret key primitive. And another one is public key primitive. Public key primitive, in this case, we are having two algorithms, encryption and decryption. And these two different algorithms, in some cases, these both may be same. Like in RSA, both algorithms are same. So we are using two different keys here. So important part is different keys, two different keys. So in this primitive, we are using public key and private key so that both key are linked mathematically. Some serious mathematics is behind those. That private key and public key are linked. But if public key is known, no one can get private key from that public information. So basically, cryptography starts with symmetric key cryptography. When it was said that Julius Caesar was there, he wants to send some information, and he used very first procedure. That procedure is known as symmetric key cryptography. Some plain text is given, and a common key between two parties is given K. If we are encrypting that plain text with the help of that key, and finally we are getting ciphertext, and this ciphertext is sent to receiver, and receiver at his end uses that same key, same private key. Keys are common. Very important point is that keys are common. Uses same key and finally gets back plain text. So this is symmetric key cryptography, and this is very efficient and fast algorithm. And today, I think everywhere symmetric key cryptography is being used. Simple model, very simple model, nothing complex here. And it provides integrity and confidentiality. 4 parameters were there: integrity, confidentiality, authentication, and non-duplication. So integrity is final. Suppose message is encrypted and decrypted that message again, it means no one can change that message. So if someone is changing that ciphertext, that in that case you cannot get back that plain text message. Clear? So integrity is there. Confidentiality, if plain text is encrypted with key, the person who is having the key can open that message. So confidentiality is also ensured by this algorithm. But some drawbacks are also there. First point is secret key is common between two parties. If there are more than two parties, then suppose there are 100 parties, it means we have to share that common key among all the 100. As soon as we are sharing this key among 100 parties, it means it is a very high risk. Anyone can send any information and say that I did not send this information. So non-reputation is not fulfilled here. If A, B, C, all the three are having common key K, A can encrypt the same message, B can encrypt the same message, and C can encrypt the same message. Then no one can give guarantee that the message was sent by A or by B or by C. So non-reputation is not fulfilled. Authentication is not also ensured by this algorithm. A major problem was there in symmetric cryptography was the key distribution problem. Because of a huge number of keys. Suppose there are 2%. We are saving only one key. But if there are 3%, A, B, C, it means one key is required if different keys are required. Common key cannot be shared because common key sharing is arising some problem. So if keys are different, so a key between A and B, another key between B and C, and one more key is required between C and E, C and A for all the communications. So in terms of graph, if we say so, complete graph is required for that. So this is the diagram here. If n users in network, then n into n minus 1 by 2. So much keys are required. It means if n, roughly we can say this n square by 2 keys are required. In terms of complexity, say we can say that order of n square is required. So number of key of order n square. If 10,000 pupils are there, it means we need 10,000 into 10,000 keys, 10 to the power 4 into 10 to the power 4. So 10 to the power 8 keys are required for 10 to the power 8 people. So it was very huge number. So it was nearly impossible to manage all the keys. So on this problem, the further work was done by Diffie and Hellman. Although there were some other scientists were also working on the same area, and their work is also in literature. But credit goes to Diffie and Hellman. They gave a protocol. Key exchange protocol was there, although they did not give any encryption algorithm, any signature algorithm, but the idea was so powerful that further it was possible to make all other authentication schemes and signature schemes and encryption schemes were possible. It was Diffie-Hellman who gave the Diffie-Hellman key exchange protocol. A basic mathematics was there. If A and B are sharing some key, this sharing of key can be generated mathematically. So although I am not going to discuss here mathematics, just I want to say here, if Alice and Bob are having their private key A and B, they are sending this information by some mathematical expression to each other, and finally they do some mathematics, and again they are getting a common key. This was the key exchange protocol. So this protocol gave birth to an idea of public key cryptography. Some other descriptions are also given. I recommend here a paper, New Directions in Cryptography, and this paper was in 1976 by Diffie and Hellman. So what are the, I think Shamban should take care of these. Participants are coming and again it pop up here. So please. So private in what happens in public cryptography? Here the scenario was suggested as by Diffie and Hellman. There should be some two keys. One key should be private and other should be public key, and these keys should be linked by some mathematical function. Some one-way mathematical function should be there. One-way means if we are giving input and getting some output, by output you cannot get input. although it is very impossible in mathematics, because here need is inversion. If inversion is not there, you cannot get encrypted message decrypted again. So encryption is required and decryption is further required for that message. It means whatever function we are using, that should be invertible. When function is invertible, mathematics says that if function is invertible, in that it should be 1 1. And if you are encrypting some message, there must be a procedure to decrypt that message. So mathematically, it is nearly infeasible, but computationally, if we say there are so many hard problems in mathematics, we can say NP hard category problems are there, some exponential hard problems are there. If we use those functions, those mathematical problem as a base, some key is there, and we are encrypting these keys, we are getting some message. And for reverting those messages to get that message which was encrypted, it is nearly impossible to compute. So it is computationally infeasible. If some trapdoor is given, some information is given, with that information, it is possible to very easily we can compute the previous value. So this was the basic idea was proposed by Diffie-Hellman. So here what the picture is, some plain text is there, and we can encrypt this plain text with the help of another party's public key. Suppose Bob is sending some information to Alice, so Bob takes the Alice public key and encrypt this information with the Alice public key and send this ciphertext to Alice. Now Alice is having his private key, her private key, so she can open this information and get plain text back. So here private key is only known to owner, so risk is very low. So only I can open. If I am having private key and that key is only one, in that case I can open that information, so risk is very low. So in that case, algorithm ensures the integrity and confidentiality. It means whatever information has been sent, if encrypted with my public key, only I can open that information. So integrity is there. No one can change it. Suppose somebody changing ciphertext information, so here we cannot decrypt this information. Some error should be there. Confidentiality is again there. Alice is sending some information to Bob. Alice takes here public key of Bob and encrypting this message, plain text and ciphertext, sending this message back. Ciphertext is decrypted by private key of Bob, and Bob gets plain text message. This is the scenario, very simple scenario, and this scenario covers the problem of integrity and confidentiality. Now it comes to non-deputation. Non-deputation is again plain text. If we are encrypting this information with private key, in previous screen it was encrypted by public key of the receiver, and this time information is encrypted with the private key of sender. If sender is sender is encrypting the problem, the plain text with his private key, ciphertext is received, and this ciphertext can be decrypted by the public key of the sender. So in this way, it can be guaranteed that particular information is sent by Bob. So Bob cannot deny that I did not send this information now. So non-deputation is fulfilled. Here we can think authentication is also fulfilled a little bit. That particular information is coming from that particular person. So authentication is there. What? Authentication problem is still remained. Why? These are some drawbacks. So these algorithms are very slow, even 1,000 times slower than secret keys. So today, whatever cryptography is being used, we use in initial phase this public key cryptography to generate keys, and after generating some secret keys are used, and encryption algorithms, whatever are being used, those are symmetric cryptography. So symmetric systems are being used. here authentication problem is still. Why? Because Bob is encrypting with his private key and sending this public information to Alice. Main problem is how can Alice have this guarantee that whatever information was encrypted with the private key up, and whatever certificate, whatever information is she is getting from that this is the public key, this is my public key. Suppose in place of Bob, some third party is encrypting that message, sending that I am the Bob. So that situation cannot be handled. Impersonation. So impersonation problem is here, and due to which authentication is again on a stack. So this scenario leads us towards PKI. So manage the identity of all the participants. This scenario needs, and we need for this PKI. Before going towards PKI, just I want to discuss your digital signature a little bit. A digital signature is basically, it is giving the guarantee that particular message is signed by a particular person. So it gives integrity of message. Message has not been changed. The originator of message uses signing key. Basically, he uses private key to sign the message and send the message, and digital signature when received by a on at the receiver side, receiver simply verify uh, by decrypting that information by public key of that person who is guaranteeing, who is giving guarantee that I am the person and I'm signing this key. So basically this is reverse part of encryption algorithm. In encryption we are using receiver's private key, receiver's public key, and digital signatures we are using sender's private key. So algorithms are same. So digital signature is actually some message is given. So what we does, we take hash of this message, and we are getting some digest of fixed length, and this digest is encrypted. So we are getting here a signature. So encryption of this digest is signature. So message and signature, these both things are sent to receiver. Through channel, you are sending message, and we are also attaching a signature. As a receiver end, message is again hashed because you cannot revert back. So hash can be done only. So message is hashed, and on this side, decryption is done. So here expected digest is received, and here actual digest value is received. So after comparing both are same, guarantee can be given that a particular message was signed by particular person. But why should I trust what the sender claims to be? So for this again, guarantee comes, and this scenario is also covered in PKI. So another part is digital certificates. So digital signatures are there. Guarantee will come from PKI. Okay, that digital signature is valid. It is fine. But we are just preparing tools. We will use these tools to create digital certificates, and we will put stone of PKI there. So what are the digital certificates? Digital certificate is a binding between an entity is public key and one more or more attributes relating to identity. Suppose I am claiming that I am Amit Awasthi from Gautam Buddha University. So digital certificate is containing this information that particular person who is having this private key is Amit Kumar Awasthi, and he is from Gautam Buddha University. These attributes are included in that certificate. So the entry can be a person and hardware, a service. Digital certificate is issued by some trusted authority, and sometimes this authority is called as CA, certifying authority. A self-signed certificate usually is not very trustworthy. This is very important. Most of the time we are programming, in that case we use self-signed certificate. So these are not trustworthy because everyone can impersonate everyone. I can sign a certificate by naming it Amit Kumar Awasthi. I can also sign a certificate, self-signed certificate by the name of Karan Singh. So actually certificate is, this is simply a collection of these all things. You can think this like as just notepad file. Some issuer information is there, some distinguished name is there, distinguished name in case common name is there, organization name is there, organization unit is there, some serial number is given by CA, that is also given in this. Validity period is given, how much time the certificate is valid. User's name is given. User information is normally called subject information. So two information are major, issuer and subject. So all the both information are given. So which algorithms are used, SHA-1, MD5, SHA-256, RSA is used, or DSA is used. It is clearly given in certificate. So user's public key is included and digital signature of CA is finally included in this certificate. So this information, having a file which is having all these information, is called certificate. So just after a few time I will create a certificate and will show you that we can get this certificate and how we are having this information certificate. Just so how are digital certificates issued? Who is issuing them? Why should I trust the certificate issuer? How can check if certificate is valid or not? How can revoke a certificate? Who is revoking certificates? So all the management of certificates, this comes under the ambit of PKI. So generation of certificate. A little bit, I just want to create a scenario to understand the PKI, what the PKI is actually. Focus here and think, two party A and B are communicating. Suppose I am accessing the website google.com. Okay, I am Amit Awasthi. My browser is, my laptop is Amit Awasthi, and I am accessing through browser the google.com. So when I type google.com, Google sends a certificate. I am getting that certificate. Now scenario comes where the certificate comes. So this certificate is coming from some third party. That third party is giving the certificate. Actually, in practical, that third party is not directly giving the certificate. In between, some registering authority is there who is certifying that particular person was google.co.in, and this information was submitted to CA, and finally CA generating the keys, private key and public key for google.com. Some protocols are there. Actually, key is given by, key is considered, key is generated by Google, and some CSR information is there sent to CA. CA is creating public key for that particular CSR request. Okay, so some CA is there. So one party, A party is talking with B, B party is certified by CA, and CA, responsibility of CA is creating certificate. And one more problem is, if certificate expires, CA is also relieving a list that is called revocation list. So every time they are with fixed time, suppose each month or each week or on each day, they are broadcasting a revoking list. So how our digital certificates are issued, we will learn here how we can create certificates and how we are issuing the certificate, and who issued. Simply CA, a trusted authority is issuing them. Why should I trust? Because there are policies, there are some rules, there are MOUs between governments, MOUs between countries, their legal rules are there. So we can trust on that particular CA. And message is signed by that CA. That's why we can consider, we can think that particular certificate is issued, and that is okay. because that CA is bound with government. How can check certificates are valid? So simply certificates you can check. Verification algorithm you can run. After running that algorithm, information comes that certificate is valid. And revocation is again important. If you are verifying that certificate is valid, suppose some signature is given and certificate is provided, certificate is valid, okay, certificate is valid, and that information is signed, that is again valid, but still there may be possibility that certificate was revoked. Actually that certificate, that information is wrong, that signature is wrong, but your protocol, your software will return that information is correct. So it is the user's responsibility always. Whenever you are checking some certificate, you are checking some signature, in that case you must take care of revocation list. Revocation, for that some other protocols are also there. So like OCSP protocol is there. Just you can send a request to a server and server returns information that certificate was revoked or not. So whenever you are developing some software, you are creating some software, you must take care of revoking certificates. So before talking about PKI actually all the managing of these all things, management of CA, certification of CA, certification by CA, structure between CAs, and how they are creating certificates, what are the certificates paths, how these certificates are working, all the management protocols, all the interoperable operable tools, these all things commonly known as public key infrastructure. Actually, infrastructure is not a shape, not a hardware. It can be software, it can be idea, it can be process. Okay. So all these things comes under the idea public key infrastructure. So before further discussion on public infrastructure, because time is a limitation, so I would like to do some practical part here, how we can create certificates. So measure, actually here we will focus on X.509 PKI. So here X.509, what is this X.509? Actually, some standard are defined in this IETF. You can check on this website. So standard is given, and this is X509 is actually article number there. So at that article number, we are getting the information about digital certificates. So that's why it is called X.509 certificates. Some other protocols are also there, like SPKI. Here just I will focus on X.509 certificates. Mostly these certificates are being used in practical scenario. Just now we will do some practical part. Just I am closing this slide here. So we will discuss your certificate authority, registration authority, certification distribution system, and PKI enabled applications. Just come to this website simply for demo. If we are opening some website, suppose we are opening google.com. And this link, this icon is here. This very simple lock is there. And if we are clicking this lock, we are getting this information certificate. If you click on this on Windows, on Linux, there is some another format. You are not seeing such type of certificate there. In Windows, we are seeing this such type of certificate. This certificate says certificate information, and very clearly a picture is here and a logo is there. This certificate is intended for purpose is given for what this certificate was used and issued to star.google.com. Star.google.com is whatever subdomain, all the subdomains are included in the certificate, and this issued by GTSCA 101. So some certification authority is legal certification authority is there, GTSCA 101, who is giving the certificate to google.com. And further, this is valid from this date to this information is given. So all the details are here. Version, which version of protocol is used. Currently we are using here version 3 of protocol. Version 3 is actually extended protocol. Extended, some other information is given. Check this. You are getting red information, version, serial number, signature algorithm, signature and hash algorithm, user, Serial number, this serial number is given by CA. Signature algorithm SHA is used here. Hash algorithm SHA-256 is used. In signature algorithm, we are using SHA-256 algorithm here. Okay, and as well we are using for encryption purpose RSA algorithm here. So who is the issuer here? And GTS, he is the issuer here, and certificate is valid from this date and valid up to 9 September this date. Subject information, subject, who is the subject? Subject is this one, google.com, and its common name is star.google.com. Its organization name is given Google LLC, and its local Mountain View, state California, and country US. This information is included. This is the public key of Google, and these are the public parameters. Which type of public parameters are being used? ECDSA. ECDSA is electric curve based digital signature algorithm. These parameters are being used here, and some green information are also included. So these all the green information are called enhanced. So in version 2 these information were not there. In version 3 these all were included. So important thing I want to show here, that is CRL distribution point. One information is there CRL distribution point. If you are using this URL and copy this information here and try to it, you are getting a list, certificate revocation list. Okay, if you are opening this list, this is the list, certification revocation list. If this certificate was revoked, you will get information that certificate was revoked. Clear? So certification list is also, CRL list is also included in this. So CRL number is this 315. So this certificate number 315 is revoked till now. So now how can we create the certificate? Come to this point. So before starting, if you are working on Windows, I am assuming you are working on Windows. On other computer you can also work. On Linux you can also do same things. Here we are installing a software on system Open SSH. Okay, I have already installed on my system. You can install your on system Open SSH. This is a open source system, and with the help of this you can create certificates. Just when you install all the software on system, simply open command prompt. This is command prompt. I am creating a folder, workshop, iCar, okay. Now come in this folder iCar. So this is the folder actually. So we are having nothing here at this time. So just I have some codes here. I will share these codes with you. So very first line, I will explain all this code. You can also check this code yourself too on website OpenSSL. This is the command OpenSSL, and further command is given here GenRSA. GenRSA is command and giving instruction that RSA key is required, and here bits are given 204 bits. So much bits are required in that key. Clear? And further piping ca.key. If you are getting this, if you are running this command, you are getting a key. Simply I am running this command here. So a key is created here in this folder ca.key. Clear? A long key is created in this file. So this is actually private key is created, and this is CA key. So this key must be kept secret. It is responsibility of CA. If you are creating some CA So it is very important to keep this key reserved. If this key was leaked, the whole system was damaged. Clear? So this key is master key and it should be kept secret. So we can now, we need the public key, public certificate of public key of this CA. For that, another code is here. Simply this code, you can also check these codes on website. I am running this command. Very simple command. Open SSL required. You can say also request new. This is type of certificate X509. Days. How much days are required? 3650 days are required. It means 10 years. Key is, which key is provided? That is CA.key, which recently we have created here. And out is CA.cert. So CA.cert is certificate created finally. Okay, so I am running this command. After running, it is asking some information. So by the way, it was deleted. So I am opening again. So desktop. Right. So now I'm running that command again. Open SSL, request new X509 days 3650, key is CA.key, and output file is CA.crt. Run this command. So some information is required. Country, which country? Suppose we are in India, so we are writing India. State here UP. Locality, Greater Noida. Organization name, Sharda University. Organizational unit, computer information center, suppose CIS, computer information center. In short, we can say CIS. Common name. Common name is actually, this is full domain name, maybe like CIS dot Sharda University su.in, su.ac.in. This is your full qualified domain name. And finally, email of person who is taking care of this CA. Otherwise, you can leave also blank. So finally, a certificate is created here. Look at this. This certificate CA.crt is created, and if double click on the certificate, we are getting this certificate. This certificate is very similar to that certificate, whatever was given for Google at there. So just see here, certification information. The CA root certificate is not trusted. This is given. To enable trust, install the certificate in the trusted root certification authority. So this certificate is actually not trusted. Clear? This certificate issued by itself. So CIS su.ac.in issuing this information and issued to cis.su.ac. Same person is issuing to itself. Okay. Details, all the details, version is given, serial number is given, signature algorithm is given, hash algorithm is given, all the information is given here. Whatever we are using through this code. And certification path, because this is very first authority, so there is no path, further path is given here. Okay. Now we are also creating a client certificate. Okay. Now I am creating a certificate for Amit. This command I am repeating. Open SSL, Gen RSA. This is keep it. You can also remove this part. This is not mandatory. Simply open SSL, gen RSA, and file name amit.key. By default, it will take 2048. So in this case, we are again getting a key amit.key. Key is created. This is RSA private key. So all the mathematics is behind this. So that is I am not discussing here. Now certificate is required. For certificate, this time actually certificate is required by me, and I want the certificate should be signed by that CA. So signature of CA is required. I am not creating self certificate. If I am running previous command, in that case I am getting a certificate to Amit that was signed by Amit. But actually this time certificate that should be signed by the CA. So this time it is required to create CSR request. Okay, so this is the command to create CSR request. OpenSSL required new key is amit.k and output file is amit.csr. CSR file is required. So we are typing here amit.csir. Their subject is common name is Amit. So this information, other information may also include here cn, on, some other commands are also there. You can use all those commands. You can take help of internet for further details. So whatever information you are giving under the subject, all the information included in the certificate. So some tags are there. So take care of those tags only. So CN is for common name. So I am taking common name Amit. Subject is common name Amit, and I want to create a certificate request. So just running this command, a file is created here amit.csir. Actually a request is created. This request is created. If you are sending this request to any person, suppose some trusted authority VeriSign is there, GoDaddy.com. If you are sending this certificate request and asking them to create certificate, they will sign certificate, and that certificate will be corresponding to your key amit.key. So key is actually created by you, and it means that is confidential. And you are sending the CSI request. CSI request is actually signed by the CA. So now finally this request when comes to CA, CA signs that request by using these commands. Open SSL X509 required days 3650 amit.csir. In file is amit. So my request is included there. So CA is actually CA.cert. His certificate is CA.cert, and his private key is required for signature. He is using private key CA.key and sets a serial number 01, and output file is amit.crd. So when he is running this command, the subject was Amit and getting CA's private key. After getting that private key, the certificate, the CSI request was actually signed. And finally, the certificate was created, and this certificate is here, amit.crd. So we are getting a certificate here, certificate information. Windows does not have enough information to verify the certificate. Issued to Amit and issued by CIS. This was the CA actually. So CA issued and certificate to me. Clear? And this is the validity period of the certificate. These are the further details, whatever required. And this is the certification path. Nothing is here. So because it is not very convincing that certificate is coming from legal place. So Windows is not giving any guarantee. Now I will make the certificate valid in Windows. So there's a little step here. CA.cert, open the certificate, and from here install the certificate. I'm installing the certificate in local machine, and in local machine I am choosing here place certificates. So this is the place trusted root certificate. So I am keeping this root certificate in the trusted root certificate. Actually, in trusted root certificates, a lot of certificates are placed on this trusted roots by Microsoft itself. So if I am putting my certificate in this trusted root certificate authority, so what happens? Now, my root, now my CA is valid CA. If I am opening the certificate now, there is no error this time. See, certificate information. The certificate is intended for all issuance policy, application policies, and this is very valid certificate. No red sign is now here. So details are there. Certificate path is this, and certificate is okay. Here it is written. Certificate is okay. Again, and this time if we are opening this Amit certificate on this computer only, this is again valid certificate. The certificate is intended for all application policies. Certificate issued to Amit, and why this, and certificate is now valid. You can check it. The certificate is okay. And this time we are getting the certificate path. Amit was signed by CISSC.ac.in. So this is valid path. Clear? So in this way we can create certificates. Important point is here. I am not giving description of CRL. You can read further information about revocation list, etc. For revocation list, a list is broadcasted over some server, and at that server we can go and we can check that particular certificate was withdrawn. So here you can see also here serial number. I was given serial number 01. So serial numbers are given to all the users for which I am creating certificates. So by serial number we can block that serial number. We can publish a list that serial number 1 is blocked, serial number 2 is blocked. It is a responsibility of the user to check that particular serial number is blocked or not. Okay. So this is the creation of certificate. Now, if this CA certificate is in system, in that case, this Amit certificate valid can be used in as we are using the Google certificate there, a valid certificate. So important was CA certificate was in root. So here you must take care whenever you are installing some certificate in root. Then you must take care. You should be convinced that certificate is valid, and certificate is from trusted party. If you are installing any certificate in your root, so some fake certificate should be there, and even I can create a valid Google certificate here. If because my system is currently having CA, my own CA is there. So even I can generate a certificate google.co.in, and we can fish the website. If I am having the access over network, I can create a fake page of google.com, and we can create here the google.com certificate, and we can host a google.com. Actually, that is not a real google.com, but because you are having the certificate CA in root, in that case your browser will show that certificate is valid, and you will be fished easily. So take care. Do not install any certificate if it is not trusted. Clear? So this was the procedure in which we are creating the certificate. So all the information we have seen in the certificate is version, serial, signature algorithms, issuer, valid from, valid to. This all information is given. Now I'm coming again back to slide. So this was the certificate. Actually, certificate was having information. Issuer information is there, serial number is there, validity is there, user subject information is there, which algorithm was used, that is also given in this. Yeah, this one. Which algorithm was public key RSA was used. 240 bits were required for that. Public key parameters. These are the public key parameters. And other information, signature algorithm was SHA used. Signature algorithm SHA and RSA 256, and these both were used here. So all the information is given in certificate. Okay. So now how our digital certificate are issued? So this is very common way. If I want some certificate, I will create a request. There are so many tools on Base site you can create. Even if you are applying on VeriSign or Google.com, they will give a form, and if you are filling the information, they will create CSR request, and you can send that CSR request to that party, and they will sign on that request for you. So if I need some certificate, CSR request is compulsory. So I will create a key and I will generate a CSR request. I will send this information to certification authority, and certification authority finally signs this key, and a certificate is issued, and that certificate can be checked because the party certificate authority that is trusted and already included in all the Microsoft Windows, all the Linux systems, even globally all the government bodies are including those. Done. So all these things has been discussed now. So we come to the point. So certification authority in picture, these were the component. Certification authority was the party who was signing the certificates. So this is the root trusted party. If this is corrupt, then whole system is collapsed. Okay. Now, second one is registration authority. What is the role of registration authority? Actually, registration authority is not signing the certificate. It is just suppose some certification authority in between. That certification authority is coming to me and verifying my Aadhaar card, my PAN card, that I am Amit Awasthi, and taking all the information and send this information to certification authority. That particular person who is submitting this information, that person is valid, and on that behalf, certification authority signs my certificate, my public certificate. So this is the role of registration authority. So this actually works under the CA. Certification distribution system. It can be think as some hierarchical system. CA, some sub CAs are there, some RA, some sub RA, some sub RA will be there. And last one is consumer, PKI enabled application, like browser. My browser can consume these certificates. If I am signing some document, so in verification site, it can be used that that certificate is required for verification. So these are the public PKI enabled applications. So this is simple model. Here, this is a CA, and CA, this is the RA, and this is the application service. This is remote person, this is local person. Local person can submit his information to RA. RA sends information to CA. CA signs his certificate, and the person is getting certificate. In similar way, remote person is sending through internet the information to RA. RA is verifying information through, it can verify through internet, or it can verify physically too. So it's responsibility of RA to verify particular person. So after verifying, it is getting CSR request, and CSR request is sent to CA. CA is filing, signing the remote person, and similarly, and hardware or some application device, this also can have some certificates. So CSIR request some if you are having some server, so for server similarly certificate request is generated. Particular server, you are generating certificate request, and that certificate request is submitted to RA. RA again sent to CA. CA signs, the signed certificate is given to particular system, and that certificate is installed on that hardware. And this is the responsibility of CA, is to broadcast the list of certificates and CRL. He is also broadcasting all the certificates and CRL here indirectly. So user's responsibility is there whenever he is verifying the certificate he is using, he is checking the validity of certificate, he or she must take care of CRLs. So certificate authority's role are key generation, digital certificate generation, certificate issue karna, distribute, revocation, and key backup, recovery, cross certification. All these responsibilities of CA. I think we have a little idea of CA now. Registration authority, the role of registration authority is certification information, face-to-face registration may be there, remote registration may be there, like through Aadhaar card, for example. Automatic registration sometimes are there. Revocation, RA are also broadcasting their revocation list, because suppose some CA in India is there, and if he is broadcasting revocation list, it is huge list. So some responsibility is also shared by RA. RA is regularly sending revocation list. This list is very small and very easily accessible, because I think if CA is generating a 1 GB list, so it will create some 100 MB list. So 100 MB is accessible in comparison to 100 GB. So RA also using revocation list certification distribution system. So it is just like a type of server where you can think like repository. All things are stored. All digital certificates are stored. Our CRL are stored. Some databases are stored. For example, LDAP. You can check about LDAP. LDAP is a directory. You can think as certification distribution system. Certification revocation list is having these information: issuer, time of this update, time of next update. I have shown you a certificate revocation list there for Google, and CA signature is also there, so you can go further. CRL are published by CA basically, but sometimes sub CA or some RA also publish CRL. It is responsibility of user to check CRL. I am again warning it. An alternative is there. This is OCSP servers are there. Actually, the problem was there that the CRL list was too hard, too lengthy, too bulky. It was in GB, so it was very difficult to verify quickly. If you are accessing 10 GB file, it will take minutes to download. Even sometimes it will take hours to download. So if you are going to validate some document and it is taking hours and days, then there is no meaning of validity. To make feasible this situation, a protocol was designed in which a server is there. Server is actually taking request. Which certificate you are asking? You are giving the certificate. I am sending the certificate. Certificate number is this one, and some certificate identification is there. This is the certification code. This server receives this information, and finally this server works in behind, is taking that, fetching this information from the databases and just returning you back the information that particular certificate is valid, or not, it is revoked or not. So these are very high performance servers. They are working very quickly and very fast servers. You can think like supercomputers. So this is the scenario. Here user download CRL, and CRL is coming from CA. This is the very basic idea, and this is the OCSP idea. User is submitting a request, and this OCSP server take care of talking with database, and this database is created by CA, and this after checking this database, OCSP server returns the answer that certificate is revoked or not. This is the very simple protocol. So these things are required. Some cryptographic functionality should be there in your applications whenever you are planning some applications. So cryptographic protocols must be included in that application. Storage should be secure, like key is stored and key should not be opened. Like in my case, CA.key was open. That should not be opened. It should be taken care by application developer. So digital certificate handling, how we'll manage this certificate, where we will put this certificate, and from where we will access the certificates directly in applications, directory access, and communication facilities like bridging between applications. So one thing again I want to show here, because I'm coming back on my screen. certificates are not these type of design. We are not saying certificate of this design. Actually, certificates are if we are opening this file in Notepad. Just open this file with Notepad. So we are getting this request. Actually, this is certificate. So this mathematics is certificate. Okay. So mathematically we are getting this information is designed by Microsoft that is visible like that. So they are decrypting this certificate information and showing the information there in form of certificate. So in sometimes in Linux you are getting some other way of certificate. You are not getting certificate of this type. This type certificate is not there in Linux. Okay. On Mac you will see some other type of information. Yeah. In Edge you are getting some other type of information. So it will depend on browser, on system, which type of certificate is shown to you. Now, so trust and legal issues. So why should I trust a CA? I think answer is there. How can I determine the liability of CA? For this purpose, all the policies are made by government. Certificates, hierarchy, and cross certification. These will give guarantee to trust. You can trust a certificate because a certificate is generated by a certification authority, and that certification, sub-certification authority may be certified by some other authority. In this way, you will get some hierarchy, some cross certification rules are there. And for liability, there are some certification policies are given by governments, and these certification policies are also you can get on websites who are certification authorities. Like VeriSign, you can check the VeriSign authority. They will also provide some certification policy rules there. In real world scenario, it is not possible that I directly go to CA. You can think CA is directly, someone can ask CA to sign, RA can ask to CA sign, and CA can also ask to CA sign. Some CA sub CA may be there, and there are two RA under this. Another situation may be CA, and this is remote registration authority may be there. This is in between internet. So this is the directory services. These are the CA, and this is again one registration authority is connected with sub CA, and these are the local registration authority are also there. So some more other practical situations are there. So do not think that we are going to directly CA. We can go to local registration authority, and that will take care to sign these signatures for your CSI request. So you can think like this. These are the trusted. These are the cross certification scenario. Suppose this is one organization and this is another organization. This is Google Trust System. This is VeriSign. This is GoDaddy. They are mutually signed each other's certificate. This is also the scenario. This is called trust certification. So all the certificate policies, this is a document that's set by the certification authority, and they are giving the rights and duty, the obligations are all details are given in these policy documents. Whenever you are getting a certificate, you can check the certificate policy on the website. Every website of certification authority has this information. Certification policy includes these all parameters, community applicable, where we can apply these, what are the major policies, what are the right and liabilities, identification, authentication, how can be done, what are the guarantees, technical security, what are the security parameters are being included, certificates, CRL, where the CRL is, how they are publishing, how much time they take to publish CRL, all the information is given. And these all information comes as a single name certification policy, although there may be a lot of documents for that. It is not necessary that they are having a single document for all. So I'm not going in detail for that. So we have already discussed these things. IETF standards, X509 certificate, we have already discussed. PKI management protocol was discussed. Certificate request format, CSIR, I have created CSIR request and showed you. And LDAP and OCSP, these are the software you can use for providing revocation list, etc. And this is the website where you can get all the details about the certificates, all the definitions of the certificates, actually what the certificate, how they are created, what is behind that, what the mathematics is being used, what is the protocol required, all the details is given in these standards, and these standards are given on this website. So finally, this identity is not enough, some other attributes are also required. For that, some other protocols also there except these certificates, although I am not going to discuss all those here. So this was the final. Thank you. Thanks a lot.
Yes, sir. There are some questions from participants.
Yes, of course.
Yes, sir. Wait a second. Sir, there is a question from Rajnish Raina. He's asking about an issuer is Google Trust itself. Can it be considered as self-certification?
One major authority, topmost CA, that is self-signed, and that was made by consensus. All the governments or accepted it that this certificate is generated by particular person to particular person. Every CA is not self-certified. Only one certificate, main certificate, that is certified by itself. So GTS is actually global service, and that is certified by itself.
Yes, sir. There is a question from Shruti. What is the purpose of CRL list? Please explain once more. She is asking
CRL
about
list,
CRL list.
Purpose of CRL list.
Yes, sir.
So purpose of these lists is actually whenever suppose someone is creating me, I am member of Gautam Buddha University, and Gautam Buddha University is having some registration authority, and they are creating a certificate for me that Amit Awasthi, I am Gautam Buddha University, I am from Gautam Buddha University, and after a few days I left that university. Suppose today I am leaving this university. In that case, if tomorrow you will check my certificate, that certificate would be valid, because no, I am not returning that certificate back. I am producing tomorrow a certificate to you and saying that is I am Amit Awasthi and I am from Gautam Buddha University, although that is not valid because I left the university. So in that case, what happens? Gautam Buddha University RA broadcasts a CRL list, revoking list. This is called certificate revoking list. They are published a CRL, and when it is responsibility of user who is checking my certificate, he must check the CRL list of certification authority, that particular certificate is revoked or not. So if you are checking my certificate, you also check the Gautam Buddha University's CRL list, that my certificate is valid or not. So this is the basic purpose of CRL list.
Okay.
If you are not checking that, it means maybe some frauds there.
Okay. I hope you understood the concept of CRL list, Ms. Shruti. And the next question from Prashant sir. Whether any software needs to be installed to execute OpenSSL command?
Yes, Open SSH. I told in very first, I opened the website on Google. Just I am again sharing it. Open SSH. This is the command. This is the open source software. You can install, even you can install on Linux. You can also install on Windows. The software is common. So this is Open SSH. This certificate is required to create certificates. Okay. Some other tools are also there. Some Java, you can use Java. JDK. With the help. Actually, website is
sir.
not. Some error is there. JDK, if you are installed JDK, so with the help of JDK, you can also generate the similar type of certificates.
Okay. Sir, there is another question from the same ID, Shruti. Will you please share the commands so that we can practice and explore it using OpenSSL?
Yes, I will share. I will send these PPT and these commands to you. You can share this to all participants.
And she is asking one more question. I believe, as Sir told, it's an open source software, should not be
Yeah.
required, though we'll have to explore. cas.su.ac.in issuing a certificate to Amit is trusted.
At this time, it is not trusted. It depends that if you are considering CA as a root certificate, you trust on cis.su.ac. You trust on that. If you trust on that, then Amit certificate is trusted. That certificate is created by that authority. Clear? Because root certificate is not trusted, in that case, Amit certificate is not trusted. So it depends on you. You are considering cis.su.ac.in as trusted authority or not. It may be trusted for a particular group, like you are Sharda University. You can have this type of CA, own CA. At Gautam University, I can have my own CA here. Okay, so we can trust on CA. If we are trusting CA, in that case, we are trusting certificate. It may be case a certificate is trusted in Gautam Buddha University, it is not trusted in Sarda University. A certificate is trusted in Sarda University, that is not trusted in Gautam Buddha. This possibility is there. For that, you can use global certification authority like VeriSign. If you are getting certificate from VeriSign, you can get certificate that is trusted everywhere, because every software, every hardware is having trusted root certificate of VeriSign certificate.
So, sir, the authority plays the major role in this, right? This is what you mean to say, na? Like when you are explaining this thing. Sorry, I have unmuted myself because there was one more query. So I thought.
Yes, of course, you can.
Okay, so
I'm not getting your question. Repeat, please.
Sir, the same question which you are answering, I'm Shruti itself. I was just asking this, that when this cis.su.ac.in is issuing a certificate to Amit, you said it is trusted if we trusted the authority, right? Then only we.
Yes.
Then only Amit certificate is trusted. Well taken, sir. So now,
because my certificate was created by the key of that private key. It must be ensured that private key should be secret.
Okay.
That should not be opened.
Right, sir. And sir, later on, we saw when you were explaining the things that issued to and issued by become the same, right? So in that case, it was valid. You explained now. Issued to and issued by also became the same URL.
Practically, if you are using on your computer, it is valid.
Okay.
Like you are working on some web server and you want to access some HTTPS protocol, so you can generate a certificate, self certificate.
Okay. But
like I am giving and one more example I am giving. On Play Store, suppose I am making some Google app.
All right.
And signing this by some certificate. So for this signing purpose, I can create my own signed certificate that is valid.
Okay. All right. Okay, sir.
Yes.
Thank you, sir. Thank you so much.
Most welcome.
Hello.
Next.
Sir, I think questions are over. How a globally verified certificate is created? This is a question from Tara.
Globally
How a
verified
globally
certificate.
verified certificate is created?
So for globally verified certificate, you have to pay. There are so many websites. Like you can check the website godaddy.com or VeriSign. These are the and there is one more site, Let's Encrypt. This is open source, free certificates are provided by this website, Let's Encrypt. LETSENCRYPT. Let's Encrypt is the website where you can generate your certificate. Free certificates are possible. Those are global certificates.
Okay, sir. Thank you, sir. I think the questions are over. So let's wind up the session now. Thank you, sir, for sharing a valuable session on PKI. Now we will have a break of 10 minutes and we'll join at 11:05 after this break. Thank you all and thank you, sir.
Okay, nice. Thanks for.
Hello. Sir, Prabhat, sir. Hello. Prabhat, sir. Hello. Good morning, Tejpal sir.
Good morning.
Actually, here I have announced 10 minutes break. Hello.
Hello.
Sir, I have announced 10 minutes break. So,
Okay.
within 5 minutes, we will start the meeting.
Right.
Okay, sir?
There is a background noise. If we can control it.
Yes, sir. I'll make it mute all.
And one more request. This is a correction.
Yes, sir.
Yes. I don't know. I am getting echo.
Wait, sir. Let me check first.
Yeah.
Excuse me, sir. Excuse me, sir. Tejpal sir.
Yes.
Check now, sir. Is this okay now?
Hello. No. Actually, I am getting my own echo.
Okay. Because you are using two devices, I think, parallelly.
No. Let me check. I will join again. Let me.
Okay, sir.
Hello.
Is this okay now?
Yeah. Now it's okay. Good morning, sir.
Excuse me, sir. Hello.
Hello.
Yes, sir.
Yes.
Is this clear now, sir?
Hello.
Still you are getting echo?
No, now it's fine.
Okay, sir. So should I start now? I think
Yes.
everything is okay now. Okay, sir. Okay, sir. Dear all participants, welcome to our last session of cybersecurity workshop. In this session, uh, Shri Tejpal sir is going to deliver a lecture on telecom security. So let me introduce Shri Tejpal Singh, who is the director of Indian Telecom Services 1995 batch, currently working as director at Telecom Engineering Center, DOT, Ministry of Communication. He has completed his BE in Electronics and Telecom Engineering from MNIT Allahabad and PGDIT from Symbiosis Pune. He has worked in BSNL Karnal and Lucknow. During this period, he has been instrumental in planning and implementation of key IT and new technology projects of BSNL, including convergent billing, intelligent network systems. In 2010, Tejpal Singh joined UIDAI HQ New Delhi in Technology Division, where his role primarily involved planning, procurement, and rollout of UIDAI solution and setting up of data centers. He has been lead the government and the development and rollout of Pan India centralized network management system for BharatNet. Before joining Telecom Engineering Center in August 2019, he has worked on a national security project of Ministry of Home Affairs. So here I welcome Shri Tejpal Singh. Welcome, sir. Over to you, sir.
Thank you, ma'am.
Let me stop the share screen, sir. Yes, sir. Now you can share the screen.
So is presentation visible now?
Yes, sir.
So
Telecom security.
right. So thank you very much for giving me opportunity to interact with all important people working in this area and introduce about concept of telecom security, what it means. I am thankful to our advisor TEC Sangi Saab, who gave me this opportunity and connected for taking up this presentation. Till now, I think you have got across complete cyber security domain, but telecom is the building block for all IT network. So I have prepared this presentation in a very generic manner, not more technical, but focused on the understanding of telecom systems. What are the threats telecom system are vulnerable for, and how we can this knowledge of telecom vulnerabilities you can use in the cyber security domain to protect your system more effectively. So this presentation is broadly divided in 2-3 parts. First, we will refresh the cyber security concept, which you have already understood in very deep. You have very deep understanding of that. Then we will look into the telecom network, how telecom network are built, what are the building blocks. Then what are the dimension of telecom security? How it affects to the user, how it affects to the nation, how it affects to the telecom operator. So each stakeholder is affected if there is any issue in the telecom systems. Now, then we will look into the global framework, because telecom systems are, there are certain characteristics. For example, they have to be global, because you can connect to any, from anywhere to anywhere in globally. Then they are interconnected systems, unlike we have enterprise or dedicated system. So they have to be interoperable also. So these aspects, when you put together, there is a need for the global framework. So what is that framework? How that is achieved? Global interoperability, interconnectivity on the telecom systems globally. then what is the institutional framework for that, and then in last we will touch upon the legal framework which enables the protection of telecom infrastructure in the country. So just to refresh the cyber security part, this is the typical home network. It looks, you have the internet connectivity through ADSL or FTTH or whatever means, then you distribute to your TV, you have switches also, you have home theater, you have other your printers, PCs. So this is a typical home network. Now, if we move to the enterprise network, it will be a bigger setup where you will have your office. You have, if you are big enterprise using IT resources, then you will have backup site, primary data centers. Then they will be connected through the wide area network. Then you will have the links which will be hired through the telecom service provider, and you will connect all these offices. So each home network, be it the enterprise network, everybody uses the infrastructure of the telecom service providers. So mainly the bandwidth, and in certain cases there are managed services where everything is end-to-end services are provided by the telecom service provider. So how we, what are the vulnerabilities we encounter in the typical home or enterprise network? That is where we have malwares, we have typically unpatched security vulnerabilities where the patches are not applied timely, so somebody can exploit those vulnerabilities. Then there is if any organization is working in a particular domain where the data or some information is typically more important, then they may find the hidden backdoors in the devices or applications also which they purchase. There may be certain cases where admin or super user privilege are misused, basically insider threats. Then security bugs in application, and some social engineering. Through some social engineering, people get entry into the enterprise network, and then create the cyber security threats. Now, so typically in any enterprise, we are using the protocol stack, which is just summarized in this slide, where at the network layer, if you see, these layers are OSI layers. So if we map the layer 2, we have a network interface where this can be point-to-point interface, can be LAN, WAN. Then if you move to the layer 3, we have internet, where you use the internet protocol, IPsec, mobile IP, IP routing. Further, if you move on the layer 4, there you have the UDP or TCP. You might have gone through the difference between the TCP and UDP. Generally, UDP is used in the broadcast type of services like IPTV, or the currently we are this Netflix or those type of application. And TCP, where the guaranteed acknowledgement is required, there TCP applications are used. For example, banking transactions, and all HTTP protocols work on the top of it. Then application part layer is merged. There's OSI layer 5, 6, and 7 are merged, where you have the telnet, HTTP, TOFA, FTP, TFTP. So this is a typical protocol stack we use in enterprise or home network. I have used this slide to refresh the contrast of when we come onto the telecom network. There we use the very specific protocols which are generally not used in any other domain. So these are the building blocks of typical enterprise network, where we have servers, we have storage, databases, applications, identity and access management, and rollback access system, firewalls, web routers. So this is the stack for any enterprise or home network. So how do we secure this enterprise or home network? We use firewalls. we configure VLANs separately to segment the network. Then we have an antivirus solution. If it is interfacing to the internet, then we have DMZ, demilitarized zone, then secure zone. Further, if you want to limit the access to the specific users, then we have provide the VPNs or IP tunneling, network address translations. And then we put some, if there is a more security vulnerability based on the threat perception, they have, organizations have security policies, and they conduct regular security audit and network monitoring, active network monitoring. In certain cases where the important data is exchanged, for example, banking transactions or financial transactions, any enterprise level applications where the important data is exchanged, we use the encryption and SSL certificate. So encryption, though you might have discussed this encryption in previous sessions, I will just quickly refresh it, because this is also used in the telecom systems. So there are two types of encryption: symmetric key encryption, where both sender and receiver has the same key. When you want to send this text, you encrypt with this key and send it to the destination, the receiver. In between, even though if somebody can tap it, he will not be able to decipher this text. But the problem with this, this is used in point-to-point encryption cases. Problem is that both the sender and receiver should have the same key. And if it is compromised, then this encryption, the security of encryption can be broken. So generally it is used in the point-to-point communication. For point-to-multi-point communication, we have asymmetric key encryption. For example, where we use that private and public key pair. Typical algorithm, we use the RSA and ECC, elliptical curve crypto. Here we have the both private and public keys. So the sender has the private and public keys, and recipient also have the private and public key. When sender want to send this information, he encrypts the information with the public key of recipient, and which can be decrypted through the private key of the recipient, and vice versa. Here, the key exchange is not required. The public key is available publicly through this can be issued by the certifying authority, which gives the guarantee of that these are the public keys of that particular user. So there is a whole process. You might have gone through that in earlier sessions. So this is just to refresh it. So public key certificates, if you see this, the concept of public key certificates, it originated from ITU-T, from the telecom domain. So this works on the X509 standard, which was developed by ITU-T, International Telecommunication Union T standard 1988, for open symmetric system interconnection in study group 17. We will touch upon this, the activities of ITU as a whole in the subsequent slides. So how public key certificate works? When you visit on any website, you see you have to see whether that is secure or not. So either you get HTTP or you get HTTPS. If you have to get the assurance that this site is secure from which I am interacting, you need to look into the HTTPS, and that certificate is issued by the certifying authority. And how this interaction, when you connect to any banking system or any secure site, how this interaction works. From this laptop, you are browsing to a particular site, So this request goes to the server. Server immediately respond with his certificate. It is just like he present his credential to the user. These certificates come to the user, your laptop, and you can verify it through the third party who is giving who has issued the certificate. So this validation, trust, integrity is established through the third party verification. Then the client generated symmetric key for that particular session only and send it to the server. After the key exchange for that particular session, the secure session is established with client and server. Now, suppose this session goes on for long duration, so say 2 hours, 3 hours, and client and servers are interacting. There are chances that this security key can be compromised. Somebody can just monitor the traffic and then decipher the key. So during this period, there is a time interval after which this key will be refreshed. So fresh key after that particular configuration. So if you
Excuse me, sir, you can unmute yourself.
Yeah, right. So for the long duration sessions, these keys are refreshed to maintain the security of that session. So this is the basic refresh of cyber security concept. Now we come to the core telecom network. So typically, this is the diagram we see. This is a typical telecom network where we have, if you see, they are the mobile network. This is through satellite also. There can be a link which are connected to the telecom system. So all the, as I told, that telecom system are global, interconnected through different technology. So be the fixed line network, mobile network, satellite, through satellite links, radio network, everything is interconnected. So now compare it with the normal enterprise network. Here in telecom network, the threat surface is very large. Anybody can enter into the network from one interface and then create security threats into the whole telecom network. Now on the top of it, this is not limited to the countries. These are interconnected and they are interconnected globally. So the threats can emanate from the other countries also. We will see the use cases for the same. So internet, mobile, fixed line, satellite, everything is converged. Now just to, we will touch upon two core network. One is the mobile network and then IP network, which are the backbone of the current generation of the technology. So if we see mobile network, we have user who owns their phone. Then we have the radio network through which these devices interact with the telecom system for the internet or voice calls. So technology wise, in 3G we say node B, and 4G we say E node B. So these are the interfaces, just like building block we have seen from the normal enterprise network. These are the building block of a mobile network. Now this is a radio interface. This is connected to the core network. Now this core network will consist of the record of all subscriber, because we have the prepaid and postpaid subscriber, then billing system, and then gateway. You can access internet also. You can access make the voice calls also. So there will be billing and charging system. And in prepaid cases, you are in real time, your charges are monitored. And then when after authentication, authorization, your call matures or your internet access is enabled. and then it is connected to the external networks also. So this is a duplication of network. Multiple operators are there, so their system will be interconnected, and so on. And this is repeated at the global level. So if you see the protocol stack of mobile communication is entirely different. The requirement of the system are different. Therefore, the protocols are specific because the performance level, type of data they handles it entirely different. So this is the protocol stack for the mobile communication, where you have this BTS. This mobile device connect to this LTE eNode B. Then it has to be. It is not directly connected unless it is authorized and the access is provided. So there is a separate signaling network. For example, when you switch on your mobile, the identity of your devices has to be established. So this mobile sends its identity, that is called the IMSI, International Mobile Subscriber Identity, and then it is sent to the through a signaling channel to the HLR, where it is verified, and then only the access can be you get the signal, and then access can be provided. Now, if you want to make call, again your credit, if it is a prepaid mobile, your credit has to be checked. So there is a separate signaling channel, and then each layer. If you see this physical layer, the MAC layer, then there is a radio layer, in between radio layer also. There is a protocol defined, that is a specific. And then it is again verified through the telecom, TCP and other protocols, or also interwork. So if you see, these are the signaling packets are traveling through the separate channel, and then actual your internet or voice call travels through a different channel. Reason being because the channels are only allocated when the whole authentication authorization is successful. Spectrum is a scarce resource, so unlike this landline or those networks where these channels are dedicated initially itself, in the radio it is not done unless you are authorized, you are the valid subscriber. Till that time, the all signaling is done through a separate channel. And there are issues we will discuss. These signaling protocol also create some security threats. So this is a typical telecom protocol stack. Link layer, if we see, in addition to Ethernet, we have this WPA and other. These are common interfaces. Network layer, this is the mobile IP node. So there are some specific protocols for the telecom systems. For example, streaming protocols, H323, you might have heard. This video conferencing and video calls, they use this protocol. So how this traffic will be carried on the telecom network? This protocol defines that. Because this video conferencing and this other similar streaming services, for example, your IPTV, they use the UDP protocol, and UDP doesn't assure you the quality of service. So on the top of that protocol, you build your quality protocol which can deliver the quality of service on the top of a protocol which doesn't guarantee the quality of service. So there are streaming protocols built on the top of it. So this is the one of the key protocol in the telecom network. This protocol was developed way back in 1988 to solve some problem of this is a common channel signaling. So earlier in the PSTN network, the signaling and the voice path was same. So what was happening that the people can dial it, tap it, and dial it, the ports, and bypass the charging. So this was conceptualized as a remedy for that, so that all the signaling, when the call is established or call tear down, everything has to be traveled on the separate channel, and other channel will carry the voice only. Now, subsequently, what happened? This protocol has been used in the mobile network to interconnect the different MSCs or different nodes. So the weakness of this protocol have been exploited. We will see the use cases, and that is one of the biggest security threat in the telecom systems. So if we can summarize it, the building block of telecom network consists of carrier grade routers. So these normal router what we use in enterprise have certain processing power, certain they can carry certain traffic. However, when you just imagine that this all traffic is carried by the telecom service provider, so the type of routers and switches they have to use have to be very high processing capability, and they have to monitor the quality of service. They have to manage them centrally. So there are certain characteristics specific to the telecom to cater the telecom traffic. Then we use the firewalls, and then there are transmission network. Now these transmission network interconnect with the the core, the end equipment, the carrier grade routers and switches. They can use the fiber, they can be satellite link, they can be radio links. So, and these transmission network also may have some vulnerabilities. Then we have the typical AAA system where authorization, authentication, and accounting is done. Then on the top of it, there is a system FCAPS where we have the fault management, configuration, accounting, performance. So whatever provisioning is done, your quality of service is monitored, the performance of the network is monitored. This is similar to the network monitoring center or an NMS we have in the data centers or in the enterprise, the performance management system. Then security and billing. So in mobile network, what we have is this specific to the mobile network. We have the radio network. We have this radio network interfacing to the core network here, where we have MSC, then HLR, GML, SC, and home subscriber location. So all details are location related, and other things are stored. So there are multiple systems, and they can be misused. So if we see the dimensions of telecom security, so is there any questions, or we take it end till now?
Sir, till now there are no questions. Maybe after the session they will be asking questions.
Right. So broadly, if we can divide the dimensions where the telecom security can affect, so we can say group them in the user security. Certain aspect affect the user security also. For example, somebody can duplicate your SIM, or somebody can take your SMS for the financial transactions. So these aspects affect the users directly. Then another aspect is the telecom system security. So they affect the telecom operators itself. For example, somebody can use the telecom network without paying. So they bypass the normal channel, and then they pump their traffic through the some other channel, and then they avoid the billing. Then third dimension is the national security. So any vulnerability in the telecom network, for example, caller ID manipulation and similar other things, they affect the national security also. The criminals use these systems to evade from the law. So we will look into each aspect of these dimensions and some typical use cases, how they are misused, and some measures also in this regard. Sorry. So if we look from the perspective of user security, user purchase their own mobile devices. Now, the mobile devices itself can be duplicate. Uh, it, uh, it can cause that threat. It can be, if it is duplicate and then it is not authorized, there may be some certain application on the top of it, which can take out the data from those devices. Then SIM cloning also. So somebody can clone the SIM and then make the calls or perform some transactions through your using your identity. So practically is a identity theft, and user is become the affected party when the law enforcement agency takes certain actions. Then data traffic and voice call, somebody can tap the secret, means personal communications, and somebody can tap the traffic also. For example, if you are making some transactions and somebody who get hold of your SMS, OTP and other things, it is also causes a threat to the user. Now, if you see your SIM, it contains a lot of data. It contains the security keys. What we have discussed in the previous slides, the security, the exchange of information between the SIM or your mobile device and the radio system of a mobile network is encrypted. But these keys are stored in your SIM when it is issued to you, and these keys are used for encrypting the information for exchange between your mobile and the BTS or the mobile system. So it contains very important information, and if it is cloned, then it can be misused. So this is the one aspect which affects the users. So, for example, if we take how SIM can be cloned, so there are techniques. They use the signal differential power measurement. So these keys can be, they decipher the keys which are available on our SIM, and then they can clone your SIM and then do the transaction. One of the vulnerability point is here, where in certain offices or locations, they install the femtocell, so to increase the coverage in the network. Now, if you see this path, when normal path with the BSC is encrypted, it is secured. The security of this system is monitored by the central system. Now, if call is routed through this system and this is not hardened, the security of this device is not monitored or not hardened properly, then it can create a security vulnerabilities in the through this femtocell installation. Now, if we see the telecom system security, as we discussed this signaling system 7, SS7 protocol, this was developed way back for different purpose. Subsequently, this same has been used for the interconnection of mobile systems, and the vulnerability of this protocol has been misused in a number of ways. So this protocol is used between two nodes to one, tear down and make the telephone calls. So when you are calling from your mobile, after the radio network, it enters into the core network, and then call has to be routed. Now, call routing between two nodes of two network is through this SS7 protocol, where the signaling is done through this protocol. Now, this protocol assumes that the two nodes which are communicating with each other, they are trusted nodes. Now, if there is a compromise on that node, it allows the user to route this SMS traffic or any other traffic to any other node. And it can be, when it is forwarded, one copy of it is forwarded to the another node, then its integrity is compromised. So subsequently, so the initial purpose of this protocol was for tearing down and connecting the telephone calls. Subsequently, this protocol has been used because there was no other protocol evolved in between. Same protocol has been used for the local number portability, prepaid billing also this is used, and then SMS service. But the vulnerability still remains, and if any node is compromised, it allows the traffic diversion to another node. For example, I can connect my system to the telecom system, for example, EPBX. I can connect onto the SS7 protocol. And if the person, if I can get hold of some person with that telecom service provider, he can configure the node that telecom service providers node that SMS going to this particular number can be forwarded to my node on the EPBX, where I can get the OTP and then do the transaction. So this can be used, the vulnerabilities can also be used to track the movement of cell phone users from anywhere in the world. So since this all telecom systems are interconnected throughout the world and they use this same protocol, anybody can track if any node is compromised, this location details can also be tracked for a particular user. The eavesdropping is also possible by using the protocol to forward calls. So this is basically signaling, it is a signaling protocol. It controls how the call will be connected or how it will be disconnected. So if it can also be used to send your traffic to another node and your call, and then somebody can listen it, because in the normal call interception, legal interception also, the same process is used. One of the major example in the European countries, this protocol was exploited to bypass the two-factor authentication. So to safeguard the online financial transactions, the banking system started using two-factor authentication. In addition to the username password, they were using the OTP also. Now, when one lot of cases came up regarding a banking fraud, where the transactions were done through the bank in an authorized manner, because with the successful two-factor authentication, but the actual bank account holder said that they have not done this. When the matter was investigated, it came to notice that this SS7 vulnerabilities, which allows the forwarding of this SMS traffic to another node, that was exploited, and number of transactions were done, financial transactions were done in an authorized manner as far as bank is concerned. So the telecom system vulnerabilities was exploited. The problem is that this protocol was not meant for this use. So now these vulnerabilities are being fixed. The nodes are hardened. The nodes with the SS7 nodes, which forward the traffic, which configure this, they are need to be hardened, and then only this protocol can be used. And in the parallel, the work is going on to evolve the more secure protocol for this common channel signaling. The same protocol has been used in the gray market SMS domain also, where in generally the SMS are exchanged between person to person in the normal telecom system, where the charging is done. The traffic is balanced in the both sides on an average between a telecom service providers, and the revenue is, there's a legal arrangement. Now, when we say gray market SMS or gray market operations of calls, it means that type of traffic which is being flown through the network is not legally allowed, or legally allowed only on one side, not allowed on the other side. So here what was happening, the applications are generating the SMS and they are delivered to the persons. So there's a asymmetric traffic. So suppose lakhs of SMS generated by application, and these are terminating it to the users, but there is no the other way flow. So only the channel of particular telecom service provider is only used for one-way traffic. He is not he is used as a channel, and he is losing the revenue because there is no other way flow. So this type of activities were detected, and these were done by the bulk SMS service providers, which have taken these SS7 links through certain different purposes, and where they were pumping the SMS traffic for those channels. When they were now these channels are being monitored, and they can overload the signaling channels also, and then they affect the performance of the telecom network. So another use case, if you see the major, I have taken certain top 5-6 telecom security threats for the operators perspective, where they are losing revenue, they are affecting the telecom system, they are affecting the security of states also. So if you see the SIF hacking in the VoIP communication, so nowadays most of the traffic is now moving to the VoIP system, and somebody has taken this EPB access. They are all connected on the SIP protocol. All VoIP calls travel on the SIP protocol. Now what they do is the fraudster, they scan through a intelligent machine or dialing system. They track they dials the numbers of these systems, and then they detect the routing misconfiguration where they are allowing the transit traffic also. So then they latch on to those particular nodes, and then just pass on their traffic through that particular node, and the charging is done to that agency whose system has been hacked. Basically, trunk has been hacked, and then all traffic is passed through it, and the telecom operator ends up in losing that revenue. Then eavesdropping also, they are illegally monitored in those systems. And caller ID spoofing, this is one of the major things which is happening, and this is also a national security threat also. What they are doing, you can find a number of applications where you can download a application. You can get the number of outside country. You can, for example, there is an application text now, you download it. You can choose your number, US, Canada, a number of countries. They are just providing, and then when you dial it from your own phone, you can you get a different caller ID. So what this anti-national or fraudsters are doing, they are downloading this application, when the caller ID is tracked, the caller ID is of US. They are sitting in India calling from mobile phone, but the caller ID is coming from US, UK, Canada. So there is a duplicacy of threats. One is the national security threat. They just use download application, make the threatening call or whatever purpose they want to use, and then just delete this application. Secondly, there is a revenue loss also. This call is routed through from India to US. Then it is again routed to India through international gateway, and then it is delivered. So this is both telecom security system threat as well as the national security threat. So to prevent this, what is happening is that telecom operators are hardening their system to enforce the encryption over transport layer, so that the security of the communication is maintained. Then implement anti-spoofing for SIP messages, because SIP messages are similar to they work on the IP protocol, so they can also be hacked. So they are working on mechanisms to anti-spoof mechanisms for the SIP messaging, and then strong border controller. So they this type of all this unauthorized activities on IP network, similar to the cyber security, they utilizes the misconfiguration of the system or loopholes in the security. And since there are number of thousands of nodes in the whole telecom system, owned and maintained by different operators, having different level of security sensitivity, it creates threats in the entire telecom ecosystem. So there is a ripple effect. Unlike the cyber security threats to the enterprise, they are limited to the enterprise. The telecom security threats in any of the network can have the ripple effect in the entire network of the country, as well as maybe globally also, but definitely in the country. So another top 5 attacks which telecom service provider has observed is the DNS attack. So what happens in DNS attack is these people want to take some data from the users of a telecom service provider. When they want to attack it, they know the telecom service provider user, they know that they have the largest user base, and these telecom service provider has the most important data of maintain the data of the subscribers. So billion of records, billion of subscribers, and when somebody want to use the telecom service providers, interact with the telecom service provider. Nowadays, everybody telecom service provider having the self-service portal and similar interfaces to serve their users. The billing system, they are sending you the bills. So everything is now on the web. Right from the customer complaints to the billing to the payment, everything is now the web. And then there is a huge number of subscribers. So the cyber criminals find this the honeypot. They can find lot of information if they can attack the telecom network service provider. So what they do is, in the normal case, suppose you want to access the site of telecom service provider. In normal case, you will say xyz.com, then it goes to DNS, it will give you the IP address, and it will route to the, after resolution, it will route to the correct server of the telecom service provider. Now, in case of DNS attack, what they do is they create a malicious servers which gets the DNS when your request goes to that particular DNS server, And when they have already hijacked that DNS servers, they return you the wrong address where they have already planted the similar site there, and then they ask you to enter your credential or another user details. So by hijacking, so you think that this is the valid site, but you are visiting a wrong site, you are the victim of it. And this happened not due to your fault on your side, or not any fault in the telecom service provider side, but the DNS in the ecosystem has been compromised. Now these DNS servers are hosted by different stakeholders, and if they are not secured properly, and the requests are not going to the secure DNS server, this can, if it is hijacked, then it can be disastrous. So this is one of the top threat which has been observed in the recent times. More than banking and education system, the telecom system has been targeted. The only way of handling this type of threat is that implement the real-time analytics, maybe machine learning or artificial intelligence has to be brought in, because there is otherwise there is no way of protecting this system. And similar to cyber security domain, there are DDoS attack, but they are of different nature. For example, by exploiting the SS7 vulnerabilities, they can just cripple the signaling system of the telecom network. And if signaling system is overloaded, obviously your calls will not mature, your transactions, SMS will fail, your financial transaction will not succeed. So there are multiple dimension of it. And similar to the multi-vector attacks, they take multiple dimensions and they bombard the telecom systems. And since these systems are interconnected, the ripple effect goes on to the multi-system level. They can maybe compromise in the one telecom net service provider can result into the collapse of other telecom service provider network. So the average bandwidth attack increased in the recent time to 5 Gbps in 2019 and from 2 Gbps in 2016. Nowadays, we are more and more applications are being hosted on the cloud. So any issue in the telecom network also cripples the other services which are dependent on the telecom network. And you will find very less services which are not using the telecom systems and the underlying applications. Now, these are already the telecom threat surfaces were very large, considering the nature of networks and of course type of requirement the network has. Now IoT networks are also coming up, and with the advent of IoT network, the threat surfaces for telecom network will increase manifold. So now there are efforts to just unlike the protocols that those were being used and they are being exploited. Now the effort is that these security are built in within the IoT network itself from the day one. Otherwise, if similar to SS7 or other vulnerabilities which has been allowed to be introduced in the network, and then after we are introducing the security measure, now the approach for the security in the telecom systems is changing. For example, in 2G or 3G or for that matter 4G, there was no specific security protocols, or why you say the security by design concept was not there. Now, in case of 5G, the 3GPP body for making the standard for the mobile communication, they have now introduced the security as a parallel vertical to make sure that the future networks are secure. Because this, unlike the other domains, the security has been, cyber security has been a important factor, and security by design came long back. Telecom system, due to number of reasons, the backward compatibility, interconnectivity, interoperability, they cannot implement the security in the all legs. So now the efforts are being made that they the concept of security by design. So anything which are being introduced as a new system in the telecom system, they are secure, and there is system to monitor that security. For that purpose, the now IoT network security is being taken on that level, where the standards and other things are evolving to make sure that these IoT network doesn't pose security threats into the telecom system. If you see the number of devices which are expected to be the part of the IoT ecosystem, there are huge, more than the telecoms users currently. There will be more devices, and they have to be interconnected, and they will be having the SIMs and those access control on those devices. If IoT network is hacked, then this can be disaster to the telecom network. They can cripple the telecom network. So the effort are being made that these standards are brought, and the ripple effect, the telecom systems are protected from the ripple effect of any compromise into the IoT network. And GSMA has already, GSM is the GSM alliance of operators. They have already come up with some checklist for the security of IoT ecosystem to make sure that telecom network remains secure, though IoT devices will be the more of a user of the telecom services. Just like we are the users of telecom services, these devices will be the telecom user, but they will not, they will be autonomous things. Nobody will be monitoring them. So the systems and security are to be built in from that perspective. Now, if we come into the national security aspect of telecom security threats, the top in this list comes to the grey market operations, where, as we have discussed, where grey market operations are those operations which are either legally not allowed or legally allowed in one country but not allowed in another country. So we will touch upon in detail in the subsequent slide on this grey market operation. Caller ID spoofing we have discussed, where the caller ID is tampered, and you might have seen, you might be getting calls with the spoofed caller ID. People are using these latest technology, IP, VoIP, which is easily available for doing this. Telecom network is if you see it, telecom is the building block of number of domains, means applications or services. So telecom now falls under the category of critical information infrastructure. We will, in the legal framework, when we will touch upon it, what is the importance of critical information infrastructure and what are that critical information infrastructure. The DOS, denial of service or network disruption, this also causes, for example, if your network, communication network is compromised in the time of war or any other similar scenario, this can be a disaster thing. So these telecom systems has to be secured to make sure that the enemy countries don't take advantage of vulnerabilities of our telecom systems, and in the time of adversities they should not be able to exploit these vulnerabilities and create and use for their advantage or cripple the infrastructure and do the economic damage to the country. In certain important area, there are chances that they put the backdoor trap in the telecom grade, these routers and other devices, where that they can divert traffic there from these devices to other destination and then analyze the communication, secret communication, and misuse it against the national security. So network spoofing. So generally, since the most of these core equipments are imported, there are chances for backdoor trap. So there is a framework government has come up. We will discuss in the subsequent slide, where the testing of these devices is mandated, and they can be introduced in the telecom network after security testing of these devices. Traffic rerouting, as we discussed, if there is any compromise of these devices, this traffic as a whole can be or selectively can be routed to the outside country, and the communications can be deciphered and can be misused, and some other traffic can be introduced to disguise this thing. So one of the use case, if we see the gray market operations, how they operate is, what is the motive of gray market operations? Mainly the motive lies in the differential tariffs. So the termination charges, if in India are high, then there is a motive, there is a incentive to bypass this traffic and then terminate this traffic through a illegal route. Second, the illegal operations are also one of the reasons. So if you see the almost 25% of the calls are routed through illegal channels, grey market operations from some of the major economies. The reason being the high termination charges. It is similar to the gold. If we increase the custom duty, people find it the smuggling. So this is more similar to smuggling of gold. This is smuggling of calls through illegal route. And technology, nowadays the technology is available, so they can simply set up the system quickly, and maybe fly by night, maybe fly by fortnight operator type of things. They set up these things and then do it. So how do they do it? You take a IP interface, you take a internet lease line, put a EPBX and connect it. At one side you connect it to the internet, so you can get the calls through VoIP, and you give your IP address, so you get from these international calls from the IP network, and they land up to your EPBX. Now you have connected this EPBX to the normal telecom system. You have taken the lease line from a telecom service provider, and then you are patching these calls. So whatever number that call is coming, you are automatically routing this call to the destination number, and the CLI on the destination number will be the local CLI, because in between somebody is working as a local exchange, as a EPBX or VoIP system they have put up. So what is the implication? He is not paying the termination charges, because this call is handed over to the local network as a local call. So very less termination charges or negligible termination charges are applicable. So this is the revenue loss for the country as well as this operator. Second, there's a security threat for the country because this call can is not being monitored. For the security agency, it calls look to be originated from within India, but actually this call is coming from outside the country, and maybe some Hawala operator or some terrorist or somebody else might be using this system. So our field units are on the ongoing basis are analyzing the traffic. They are monitoring these systems and then unearthing these illegal grey market operations on the ongoing basis. And they also nowadays, rather than taking a physical links, so from the telecom service provider for terminating the calls, because there is a physical verification and then telecom service provider knows that this is the location where this is installed. So what they are doing is now they are purchasing the SIM and they are connecting to the SIM block, so nobody knows where those physically that location is where they have installed the IPv6. So they are upgrading their systems on continuously and using the latest technology to continue this with this gray market operations. So with these threats and covering entire ecosystem, users, telecom service provider, and the nation itself, and considering the nature of telecom network, there is a global framework created for the standardization of telecom systems, where this ITU, International Telecommunication Union, comes into the picture. It was founded in on 17th May 1865, very old organization which has been leading the development of standards in the telecom domain, and India is the member of this organization for more than 100 years. It is headquartered in Geneva. It has three wings. ITU-T, this is for the telecom, this sets up the standards for telecom systems across the domains. ITU-R is for radio. This is responsible for the managing the spectrum across the globe. So which bandwidth will be used, which radio frequency will be used for mobile communication. Based on the availability of those bands globally, they harmonize it, they come across the finalize the bands, and after finalization of bands by the ITU-R, the technologies are aligned for development of equipments in those bands so that this can be used globally. ITU-D is for development. They support the less developed countries in development of telecom infrastructure regarding the policy support, technical supports, and other things they provide. So this is a brief organization of this ITU-T, which develops the standards for the telecom system, and that makes this telecom system interoperable, interconnected to work seamlessly. A lot of global effort goes into the background of it to create the telecom systems which are which works globally, which are interconnected and without any problem. So this how they organize it is the ITU-T, then they create the study groups. Under the study groups, then there are working parties which takes the specific domains of work area and then submits their recommendation, and they are then approved by the ITU-T. And the mandate for these study groups is given by the World Telecom Standardization Assembly, WTSA. Incidentally, India is hosting this WTSA this year and in November. If it is not, it doesn't happen due to this crisis, it will be shifted in next year. So what is World Telecom Standardization Assembly? This happens every 4 years, where the roadmap is approved for the work for these study groups, that on which domain these study groups will work, what questions they will take up, and they will develop the standard, they will do the consultation with industry and other stakeholders, country, and come up with the standards, and which will be further adopted by the ITUT and become the standards, and then future technology will come. So they starts working on the technology which will be coming into the next 5 or 10 years. They always work for the future and create and review the update or any correction required in the existing standards. So this ITUT is divided into 19 study groups. They each group takes up different domain. For example, the study group 17 takes up the security, language and telecommunication software. Study group 11 takes up the signaling requirements. So whole this domain, whatever security perspective is there, they are taken care of by study group 17, because this approach is important, because security has to be cut across. So anything you are bringing into the telecom systems, the security has to be end to end. That's why the study group 17 is responsible for security of all telecom systems. Whatever standard is coming, they see that security is built into those systems. So this is just brief. We wanted to bring you in your notice. So if you are interested into the to be part of this process, in addition to the DOT and TEC and other organizations, the educational institutes who are interested in this area can also contribute in this domain and be part of the standardization process in the telecom domain. So this is a broad security building block which ITT has developed. So this is more of a framework for the telecom security, where they create the architecture for different systems. So X800 series standards provide the security architecture and framework for different telecom systems. If you see then security techniques, X841 and that series give the security techniques for different type of systems. Then X274 is security protocols. NGN security is the Q series. Security management is the X733. So we have seen in the previous slide that public key cryptography, that was evolved by the ITUT study group 17 long back, which is now become the de facto standard that has been adopted. So multimedia communication standard, if you see H series, H323, that has been evolved by ITUT. So they have created a very good security building blocks and framework. The relevant development for the new technologies on the telecom domain fit into these building blocks, and they are expanded and updated on the ongoing basis. So just to give a glimpse of a study group 17, what they are doing currently, they take up in the form of questions. So question 1 is related to end-to-end multicast communication with quality of service management facility. So there are a number of questions on which they are working. If you see question 6, it is relating to cyber security. Question 5 is security architecture and framework. If you see this they are coming up with the working on the security of tele-biometrics. So biometric, how that biometrics can be used through the telecom system, because biometrics is a very important part. If they travel on the telecom network, how the security of this has to be ensured. In addition to the cyber security, when your applications are building, it should not be compromised at the telecom infrastructure level. And this question 9 is on secure communication, and countering spam and technical means the question 17 they are currently working. So after discussing with the multiple threats, vectors, what is the use cases and how they are can be exploited. Let us see what is the legal framework which is available to protect the telecom systems and the security of the telecom system. Now, considering the threat of backdoors and compromise of telecom systems, which can be exploited by the hostile countries, there has been an amendment in the Indian Telegraph Act, under which all telecom service operator operates. Now it has been mandated that every telecom equipment must undergo mandatory testing and certification prior to sale, import, of use in India. So this framework called the MTCTE, mandatory testing and certification, is being implemented by telecom engineering centers, where labs are created, where these equipments will be tested for the security and safety purpose. Then only they can be imported and inducted in the telecom network. So this is a very good beginning for making the telecom system secure, at least from the hostile countries, and they should not be able to use it in case of any crisis. Now, IT Act is a overarching things where also we find some protection. For example, identity theft is covered in the 66C. So password and other things which are misused by this is applicable to the telecom systems also. IT Act is applicable to the people who are managing the telecom system in addition to the normal cyber security part. Because these telecom system contains the subscriber data, as well as they maintain the telecom system where the same passwords and administrative things are also there, which can be exploited. 66F cover the punishment for cyber terrorism, and attack on the telecom system is also a cyber terrorism, and there are strict provision defined in the IT Act. 69V gives the power to authorize to monitor and collect traffic data. So there is a legal provision, and the telecom system also falls in this category. So the interception of calls and other things are done under this provision. Now, Section 70 of IT Act defines the provision for the protected system. So it says the appropriate government may, by notification in the official gazette, declare any computer resources which directly or indirectly affects the facility of critical information infrastructure to be the protected system. The government has declared telecom systems as a critical information infrastructure. So attack on the any critical information infrastructure, there's a process has been created. NCII PC or the organization has been created which facilitate the monitoring and guidelines SOP in applicable for all critical information infrastructure. So telecom being the critical information infrastructure, they are monitored. They are as per SOP, they are supposed to report any incident into their network to the authority. So there are SOP under which this critical information infrastructure works. So telecom being one, power sector is another critical information infrastructure. So there are a number of domains which government has declared that these are the critical information infrastructure, and there are SOP which are to be followed by the telecom service provider, and there are guidelines that any incidents of compromise or failure or attack on the telecom infrastructure has to be reported, and then the emergency procedures kicks in to protect this infrastructure. Now, in addition to the critical information infrastructure, there is provision for declaring the protected system. So that is a one additional step which defines the provision for severe penalties if anybody attacks to that protected system, and there are SOP for accessing those protected systems. For example, this UIDI, the Aadhaar, the CIDR has been declared as a protected system under the this section 70. Now, if any protected system can be only accessed by authorized people, and there are if there are any misuse or there are any failure of compliance, there are severe penalties. Because UIDI maintains the huge repository of Indian citizens, that's why they have taken this provision, use this section 70 to declare this is a protected system. Similarly, Ministry of Finance has declared the GST database as a protected system. So telecom systems are critical information infrastructure. They cannot be declared protected system because they are a distributed system. So they are one level below that protected system, but they are they fall into the category of critical information infrastructure. So that's all. And if there is any question, I will be happy to take and clarify.
Yes, sir. Sir, there is a question from Selvam. Is any application for caller ID spoofing, not fake caller ID?
Is there any application?
Application for caller ID spoofing.
There are multiple ways of caller ID spoofing. Basically the VoIP calls route is used for the this caller ID spoofing. VoIP provide this in the configuration of your IP, phone, and other things. They provide the provision of declaring your own ID. Now, if you don't follow that system of numbering, you can put your caller ID in that way, and that is presented as a caller ID. The way the normal system which are provided under license condition, they are legally bound to maintain the integrity of the caller ID. But the EPBX system or the people who are using these IP VoIP system for the illegal calls, they are not working in the legal domain, but the technology enables them to change the caller ID. They present the caller ID the way they want. So the agency or operator which are working under legal framework or license framework, they don't do it. But they are, as I said, that these telecom systems are global and interconnected. So if anybody routes component is connected into the system, they pump the spoofed caller ID. So they manipulate it. For example, he will get, if I have that application and I call that, he will get my correct caller ID. But when he is manipulating that call, he will present another caller ID, which is the VoIP system under his control, which is not working in the legal framework, that technology is allowed this. That is the way they are doing it.
Sir, a question from ID number 43.
Right.
How SIM cloning can be done?
So SIM cloning, the way they do it, there are multiple ways of doing it. One is that when you are going to they block your SIM, and they do the FIR, and they take the details, take your SIM to them. This is not practically SIM cloning. They are simply this is identity theft. Rather than claiming you doing the complaint on your behalf, somebody else is doing. For SIM cloning, they do the RF, the power analysis, what I covered there. So they take your parameters. This is similar to your credit card or that debit card cloning. They do the power analysis. They whatever keys and other things what I explained in the previous slide. If I can go back. So these details are stored on your SIM. So they already know your number and other things. And these SIMs are, these telecom service provider source these SIMs from the other agencies. And they are, they can be programmed through a separate system. What they need is only the keys which they get from your RFI, this power analysis or any other means. If they get access of your phone, or they can get some data from that data is compromised from the DSP side, there are multiple way of doing it.
Sir, a question from Vinod Kumar.
Ji.
Telecommunication services providing any security feature for common people for using of mobile and internet?
Yes. Telecom service for internet users, if you see many of the telecom service provider are providing you the antivirus and other similar applications where you can scan your device and protect it. Second, as a standard, unless you install some ROUS applications or wrong applications, this whatever SIM they provide, this is logged. They are the communication between your mobile device and BTS is encrypted. So that they are telecom service provider are making sure that by default this security is built into the system. But there are certain technology limitations which are there, which are being fixed or removed in the ongoing basis during the development of standards. As I said, the SS7, that is a old protocol that is now being fixed. So mobile system as such or any other system, they are securing your communication, but in between there are certain lags where there is vulnerabilities which are being misused by the miscreants.
Sir, a question from ID number 43.
Right.
Is it possible to clone our SIM without our actual SIM card?
Yes. You might have come across such cases, because this is what is this if you see this SIM contains only keys, other things anybody knows. I know your number, and only the thing says that I need to have your IMSI, subscriber identity module, the one number and your keys. That's all. So then this SIM can be, there's a small chip on the SIM. If you see this, it contains the microprocessor and this memory. If I know the keys And IMSI, in fact, what happens is if you see that these old generation SIMs, what was happening is the communication with your mobile and the BTS, that was on unencrypted channel. So when you switch on your device, what happens is you send your IMSI number, and this IMSI was unencrypted. So I can simply monitor the RF call, whatever signal is being transmitted, and this is transmitted unencrypted, so I can find out IMSI very easily. There are devices available, equipment, where I can just monitor it, and I can find out these things. There is another way. I have a device, I put across, and you latch to the particular device. So you will find that you are connecting to a valid BTS. So as soon as you connect to this device, which is transmitting signal, and it will be similar to a normal BTS, you will latch it, and when you want to latch it, you will exchange those things. So rather than means authorizing you and you making calls, it will simply take your keys and that IMSI information, and then simply put into the SIM and then configure. As simple as that.
Sir, a question from ID number 25.
Right.
What is the cost of one VoIP connection?
Cost of one VoIP connection, for example, nowadays there are plans where they are providing the VoIP connection free of cost along with the internet.
Sir, a question from ID number 43. Sir, is it safe to use Truecaller? What access permission should we give it to it?
Truecaller, see, they have their policy. You need to read their privacy policy or data sharing policy. This is a exchange of basically pooling of information. If they provide you that access, they take all those your contact into their pool. So if you are okay with sharing that data, that is up to you. You have to decide.
Sir, question from again Vinod Kumar. How to secure the EPA BX system and IP phones?
The all unutilized port, it is, you apply your all cyber security principle to that configuration. Your administrative person has to be make sure that he is not compromised. Basically insider threats are more there on the EPBX systems. So you have to monitor, the logs should be generated and they should be analyzed. Somebody should be, you should need to have a cyber security policy that should be applicable to the EPBX systems also, because that is the biggest vulnerability point. And the unused labels should be closed. No unused labels should be allowed. So that your EPBX doesn't work as a transit exchange for somebody. And all unused things and hardening has to be done. And the logs of your calls, when you monitor the unusual traffic, you have to monitor your system.
Sir, there is a question from Tara. I heard that the hacker can delay the message of banking transaction to real recipients.
Right.
Is it possible without the authority of telecom?
So, see, telecom and cyber security, the insider threats are the biggest threats. So, if there, unless there is a insider involvement from the telecom service provider, it is not possible. So, what telecom service provider are now doing, they are putting the check and balance system, where the configuration changes are logged. They are analyzed centrally on the security operation centers, and there are check and balances system. They are also putting up some machine learning algorithm also that to make sure that these things are not possible. But obviously, you cannot say that systems are 100% secure. Security is never 100%. It is ever above.
Yes, sir. The questions are over now. I hope it is understood for everyone. So let's conclude the session here. Thank you, sir, for sharing a valuable session on telecom security. Thank you so much, sir. And now we will have a break of 10 minutes. Then after that, there is a valedictory session, which is again chaired by Shri Tejpal Singh, sir. And we will be joining the session after 10 minutes and we'll be starting at around 12:50. So thank you all. Thank you, sir.
Thank you. Thank you very much.
Hello. Am I audible, sir? Hello.
Yes, yes.
Okay, sir. Let's start the valedictory session. It's a successful completion of security workshop, which is organized by ICARE team with the Association of Sharda University. Here, we have 75 participants who have attended this security workshop. So, here I would like to welcome our representative, Dr. BMK Prasad, ICARE team, to give a brief description on this 5 days workshop on security. So, welcome, Dr. BMK Prasad, sir. Over to you, sir.
Thank you. Good afternoon, everyone.
Good afternoon, sir.
Once again, I welcome you all. 5 days workshop on security conducted through ICRS under SEDCT was successful. Most of the participants discussed and cleared their doubts and learnt a lot. The workshop on security stands successful because of useful topics like attack and security, cyber crime and VAPT, authentication and validation, open source and tools, investigating and protecting network, ethical hacking, etc. were covered, and learned speakers and experts interacted with the active and attentive participants from all over the country. In future also, we would like to conduct such type of workshop, seminar, conferences, and symposium with the association of you all. On behalf of SEDCT and International Center for Advanced Research and Studies, Delhi, I am thankful to all the speakers and experts who have covered their topics and subject areas on security, interestingly with applications and usefulness. On behalf of all the members of ICRS, I am thankful to Honorable Professor Dr. D.K. Lobial and Dr. Karan Singh from JNU, who have contributed a lot overall to make all the workshop on IoT, research tools, and security successful. I am thankful to all the technical team for their handling all the technical issues seriously. On behalf of ICRS, I am thankful to all the coordinators, all the volunteers from JNU, from ICRS, and from Sharda University, Greater Noida. On behalf of ICRS, I am thankful to all the participants from various institutions and organizations who intended to learn more and more through the workshop. On behalf of ICRS, I am thankful to Mr. Prabhat Kumar Yadav, Mr. Rajiv Kumar, Ms. Manisha Yadav, Ms. Sakshi, Mr. Amrit Bawankan, Mr. Rishabh, Mr. Prashant, Ms. Aparna Bawankan, Ms. Neetu Gautam, Dr. Lata Banda, who have worked very hard to make the workshop on security a success. Also, I would like to inform that we are planning to conduct an international conference in the month of October 2020. So I encourage all the participants to keep checking the website for further details. Thank you and wish you all the best.
Hello. Hello. I'm audible, sir?
Yes, yes, please.
Okay. Over, sir.
Thank you.
Thank you, sir, for your valuable speech. It's really a very great honor to have this security workshop model for Sharda University. We really got a great opportunity to work on this workshop. Being a coordinator, I learned a lot by this workshop. I have attended all the sessions as well as parallelly I was working with the workshop team. Thank you so much, sir, for your support from IK team. Without a support and backbone, the success of this workshop couldn't be possible. So I got support from our dean sir, who gave me the whole encouragement and motivation to organize this workshop. So, not wasting much time, I would like to welcome Dr. Parmanand, Dean SCT Sharda University, to give an applications of cyber security. Welcome, sir.
Thank you, Dr. Lata.
Over to you, sir.
Thank you so much for coordinating the whole workshop in
Thank you, sir. Thank you.
excellent way. The workshop of the 5 days in collaboration with ICAR and the Sharda University has really created another benchmark for those who are organizing the conference and for the participants to look into. This 5 days workshop was focused on different areas of cyber security, to name attack and security solutions, which is headed by Dr. Karan Singh, then cyber crime headed by Dr. Arun Girdhar, then Dr. Rahul Amin delivered lecture on authentication and validation. Then Dr. Sushil from JNU told about open source and tools. Mr. Avinash Kumar delivered a talk on investigation and protecting network, and then again another session on ethical hacking. On the 4th day, on the malware detection system, Dr. Nitin Chauhan had a wonderful talk. After in the afternoon also, he taught about computer forensics. The last day, that is today, Dr. Amit has given an overview on the PKI. Looking at these topics, hopefully all the participants must have got good knowledge, awareness about cyber security. As in the beginning, I said cyber security is really a demanding domain in the market, whether it's academia or the industry. Both are working hard to create a workforce which is required and will be required in coming days. Thank you, all of you, for giving your inputs, insights, and highlights about the topic. I welcome Sri Tejpal Singh from Telecom Security as a chief guest in this session, in this workshop. I thank Dr. B.M.K. Prasad for really putting up hard work in making this workshop successfully with the team of ICAR as well as the team of Sharda University. Thank you so much. And of course, we'll have a lot of collaborations in terms of workshops, seminars, and of course, as you said that you are going to organize an international conference. So we'll be there to collaborate in all the ways. Thank you. Thank you, all of you.
Thank you, sir. Thank you for delivering a valuable speech. Now, it's a very great honor to have a renowned personality who have already delivered a session on telecom security and who is our chief guest, Shri Tejpal Singh, the director of TEC New Delhi. Now, I would like to welcome Shri Tejpal Singh to deliver an overview of future of security. Welcome, sir. Over to you, sir.
Thank you, Dr. Latha. Uh, First of all, I want to thank you, your team, ICRs, and Sada University for conducting such a relevant seminar workshop. With the adoption of this e-education, e-health, more and more aspect of security has to be taken care. As we say that security in layers and defense in depth. So security is never 100% complete. It is ever evolving, and the awareness around security is very critical. So the landscape of security threats and the threat vectors, they are always ever evolving. So this is a catch-up game. There is a strong motivation for non-state actor as well as state actor to target the systems of country and create problems. So the objective of our education system and likes of Sarda University and JNU has taken this step. We have to create the expertise in this domain to take up the challenge of the future. And until unless we have that orientation from the student or maybe engineering level itself on the security, it will be very difficult to create the expertise or excellence what our country need. Therefore, we need to make our students and faculty either dealing with the security or not. Everybody using cyber, everybody is visiting the cyber space. So everybody has to be sensitive, understanding, and be the carrier of this information and then increase the knowledge. We can only reduce the cyber threats by cyber awareness, putting up the SOPs and systems in place, training and sensitization of our staff. So this type of workshop will go a long way, and since the security, we need to have a holistic view. So not only limiting these things to the certain layers, we have to protect and secure all layers, right from the physical space, physical layer to the application layer. As far as telecom is concerned, we are providing the physical and network layers. So that dimension, if cyber experts also take care of that dimension and take a 360-degree view to secure the systems and bring that awareness for our future generation who will be the taking up the this mission of securing the systems. It will be a great service to the nation, and I'm sure that with this approach we will be able to bring out excellent expert in the cyber security domain and lead from the front. So I once again thank Dr. Nitin Rakesh, HOD, Sarda University, Dr. Parmanand, Dean, Sarda University, and Dr. BMK Prasad, ICRs, for giving me the opportunity to be part of this important session, and allowed me to give a perspective of telecom also. So if we, until unless we take the holistic approach, it will be, or there will always be weak links. So let us not leave any weak links. If we have all perspective, through a thorough perspective, then definitely we will come up with the foolproof security, cyber security solution. Thank you.
Thank you, sir. Now it's a time to announce the participants list. So once again, I would like to welcome Tejpal sir to announce the participants who successfully attended this workshop.
So I will bring out that list in the.
No, sir,
What?
I'm sharing.
Achha.
So this is the list.
So almost how many participants?
Sir, 75.
75. So there is a great mix of participation in the workshop that shows the importance of cybersecurity. People are attaching to it, and this is of course timely intervention and need of the hour. Thank you, Dr. Lara.
Yes, sir. So dear all participants, please have a look on this participants list. If there is any problem, we can talk later in the WhatsApp group.
You can scroll it.
Yes, sir. Here we have only 2 slides of this all participants. And next, thank you, sir, for sharing the list of participants. Being a coordinator, I learned a lot from this workshop, which is online. And for the first time, I have experienced it. So at the back end, we need to work a lot when we organize an online events. It's not an easy task, but still we tried our level best to achieve the quality of this workshop. This is my feedback for this workshop. So now I would like to request our participants to share their experiences of this workshop. So welcome all. If anybody want to share their experience, then I can mute them. Yes, anyone? Is there anyone to share their views? You can raise your hand. Shruti Mehta.
Yes, ma'am.
Okay. Yes, please.
Yeah, good afternoon, everyone. And I would just like to say thank you to all the organizers who were behind organizing this workshop, and to all the eminent speakers who have spared, some time from their busy schedules and have come up and have enlightened all of us on cybersecurity concepts. So, like, I have attended it thoroughly, and I really enjoyed the way, the concepts were, brought in front of all of us, and it really gave a very clear and immense picture. We have been reading it, we have been, making our students learn all these concepts since all our faculties who have, joined this workshop. But it was so smooth, the experience of taking all the concepts and going through them through these, experts at hand. So it was truly an enriching session.
Okay, it's over.
Thank you so much for organizing.
Thank you, ma'am. Thank you for your valuable feedback. So let's continue the valedictory session now. Now, one more personality, Dr. Nitin Rakesh, CSC HOD, Sharda University, who did a lot effort to reach the quality of this workshop. Now, I would like to welcome Dr. Nitin Rakesh, HOD CSC Sharda University, to give vote of thanks. Nitin Rakesh, sir. Over to you, sir.
Good afternoon, everyone. Thank you, Dr. Lata, for introducing.
Thank you.
This was a wonderful session which happened all the 5 days. And the constant thing which was up for all the 5 days are the list of participants. The number of people, they are constantly there for all the 5 days and are attending all the sessions from all the valuable speakers. I would like to thank formally I would like to thank the association which happened because of Dr. B.K. Prasad from ICARS, and because of his association, this entire concept has been conceptualized. I would like to thank the galaxy of speakers who are all involved from their busy schedule and have given a valuable time to all the participants and enriched the session with their experience. Professor A. Govardhan, Professor Karan Singh, Professor Arun, Professor Rahul, Professor Sushil, Professor Avinash, Professor Anurag, Professor Nitin, Professor Narzo Alaski, Professor Amit, and Professor Tejpal. All the speakers and all the distinguished guests, they have given a wonderful insight for the field of cybersecurity. The possibilities in future are depending in the field to a major area. And we have seen that the speakers have very intensely highlighted the areas where the hazards of cybersecurity can happen. They have also promoted the approaches where protection of networks can be done from the cybersecurity attacks. They have provided various ways and approaches which exist in recent research also, and also being implemented at various application and entrepreneur level. Even at the enterprise level, many speakers have spoken about the approaches which can be implemented as a layman. We are very thankful to all the speakers, guests, participants who have made this event collectively successful and contributed 5 enriched day with cybersecurity knowledge. Thank you everyone. And from Sharda University, we are very much blessed and thankful to have this opportunity provided by our Dean School of Engineering and Technology, Professor Parmanand, and has acted as a catalyst behind the entire scenario. Thank you, sir. Thank you, Dr. Lata, for organizing wonderfully all the 5 days without any hassle and facilitating all the sessions to the speakers and to the participants. Thank you.
Thank you, sir. Thank you, sir. There are many messages from participants who are giving feedback on this workshop. So I'll read out here. Mr. Sandeep Mahapatra, he has written that thank you for the organizing team for such a lovely workshop, and literally it's a great experience to be a part of this. Thank you all, learned a lot. So there are many messages like this. And one more is from Vinod Kumar. Congratulations to all technical team and organizer. Okay, thank you, sir. Thank you so much. So here we will conclude the session. So I'm really very happy to organize this workshop, 5 days workshop on cyber security. So let's wind up this session here. Thank you very much, all the participants, speakers, my Dean sir and HOD sir, and especially thanks to my guide, Dr. Karan Singh, and my Dean sir from JNU, Dr. DK Lobial sir, and my technical team, all from JNU, who supported me for all these 5 days with much more efforts. And they supported me a lot, like anything, like Prabhat sir, Manisha ma'am, Rajiv sir, Vikas, Sakshi, Rishabh, Prashant, and many more from JNU. And I'm really very thankful to all. And a special thanks to iCare team, especially thanks to Dr. BMK Prasad sir. Thank you so much for giving this opportunity to organize this workshop. Thank you so much, sir, and thank you all. And after this session, I'll be sharing attendance come feedback form to all the participants. So please kindly fill up the form. Thank you so much.